Okay, let's do this problem from your lab assignment, section 11.11. They want us to look at this function, the square root of x, around a is equal to 9 for n is equal to 2. That's a quadratic. And then for values between 9 and 9.6. So part A, they want us to approximate the Taylor polynomial with a polynomial of degree n. And they want us to use Taylor's inequality to estimate the accuracy, and then they want us to graph. All right, let's take a look at it. We want the second degree Taylor polynomial, which means we need a couple of derivatives. The derivative of this is going to be, well, this is like x to the 1/2 power, so this is going to be 1/2 x to the negative 1/2. And then another derivative of that will multiply these two, so that's going to give a negative. And 1/2 times 1/2 is 1/4. And then we need to subtract 1 from here, so that's going to be a negative 3/2 power. So now we want to put in values, the value of 9. So the square root of 9 is 3. So that's for the original function. Now for the first derivative, we have 1/2 x to the negative 1/2. I actually did this in my sheet of notes here, just to get a clearer picture to see what's going on. The 1/2 x to the negative 1/2 is actually 1/2 square root of x. And if you put a 9 in there, you're going to get square root of 9 is 3, so that's 1/2 times 3 is 6. So this is just give you 1/6. And then the second derivative will give you a 1/4 times 27. Let's figure out what 4 times 27 is. That's 4 times 27, 108. And that's going to be a negative number. And okay, so that's good so far. So our Taylor polynomial is going to be a 3, and then a plus 1/6, and then an x minus 9. Plus, actually this is a negative, so this is a negative, so that's a minus 1 divided by 108. And now we want to divide this by 2 factorial, which we'll simplify this in a second. And then we have an x minus 9 to the second power. So simplifying this, the 2 factorial is just 2, and then 1/108 divided by 2, it's like multiplying the denominator by 2. So let's take that out and just say multiply this by 2, and this is 216, and that should be good. So now that we have that, we have our Taylor polynomials. That's completed. They want us to use Taylor's inequality. Taylor's inequality says that we have a third derivative involved, and we want to find the maximum of the third derivative. We know that this is going to be equal to, for R2, we want this to be the third component, so that's like dividing by 3 factorial, and this is to the third power. And then we want to have values between 9 and 9.6. So if we put a value of 9 in for x, we're going to get 0, and 9.6 is going to give us the largest value. So so we want this to be less than 9.6. well, we need to subtract out 9, so let's just say 0.6. And then we take this to the third power calculator, to the third power, so 0.6 cubed is 0.216. Okay, so now we actually need the derivative. I think we have the derivative worked out over here. So we can write it several ways. Let me write it the way we would have it. This is 3/8, and then x raised to the negative 5/2. So we will use our derivative here, our third derivative, to figure out what the largest value of m is. So this function itself is a decreasing function. So because we have a decreasing function, between 9 and 9.6, if it's decreasing, the largest value would happen in the beginning, and then it'll go down from there. If it was increasing, the largest value would happen on the right end instead of the left end. So since this is decreasing, we want to know what happens when we put 9 into this function. So let's go ahead and take our calculators out again, put 9 in there. So I have a 3 divided by 8, and then I want to multiply this by 9 raised to the, now I have to put a 5/2. Let's put a parentheses around here. 5 divided by 2, negative. One of them is a negative. So our value is 0.00. Do not approximate. All right, let's rethink this. We want to put a 9 in here. Well, if this is going to be our value. So let's put a 9 in here. Let me copy this again. So let's put 9 in there. Let's skip over this step. Let's put 9 in here. So what are we going to have? We're going to have 3 divided by 8 times 3 to the 5th, because square root of 9 is 3. So one of the 3's can cancel, and so we just have 3 to the 4th. So 1 over 8. 8 times 3 to the 4th, so 3 to the 4th times 8. So 648. So I think it's going to be 1 over 648. As a fraction. So therefore we have m over 3 factorial times this thing is going to be this expression. This is the boundary that we found for m. The maximum 3 factorial is this, and then the largest value we can get is 216 from here. So we want to round this off. So we want the reciprocal of this. Is there a reciprocal? Here's a reciprocal. We want to divide by 6. And then we want to multiply this by 0.216. We want to round off to 6 decimal places, so we have how many steps here? 1, 1, 2, 3, 4, 5, and then a 5. That's 6 decimal places. I suppose this is going to round up to 6. Oh, I may have gotten too many zeros here, or not enough zeros. Alright, let's try that again. So this is 1, 2, 3, 4, 5. So that's 4 zeros. So 1, 2, 3, 4 zeros, and then a 5, 5, 5, 5, 5. And so we want to round off to 6 decimal places. 1, 2, 3, 4. Oh, this should be a 5, 6. Okay. So that's good. Now we want to check the result by graphing Rn. So Rn is going to be this here, where m is equal to 1 over 648. Well, we can just see that between 9 and 9.6, that's our interval between 9 and 9.6, we're going to get a largest value of 0.00056. And this is a third degree polynomial, so it's not a line, it's going to be curving, although some of these lines look like they curve a little bit. But I think it's going to go up. So we're going to go to 9.6. We know it's not this one, and yeah, these things look like they're lines, and so I don't think it'll be that one. So I think it's going to be this first graph over here, where the x values goes from 0 to 9.6, and then the y values go from 0 to 0.00006-ish. Okay. Alright, so that looks good. It's completed, and I hope that helps.